Unit 3.6, a quick one. It's just talking about the equivalent Boolean expressions here. And looking back at the introduction, you should realize that there are some equivalent expressions. Now we're going to look at De Morgan's laws. I'm picking that one because that one is very, very frequently used. So I'm going to slide up and show you De Morgan's laws. And then we're going to come back, evaluate, run, and see why the code is giving us what we're getting. So De Morgan's laws, distributing a not and factoring out a not. Now, in this case up here, we have P's and Q's, but when we actually write code, we're going to actually have a statement. So just remember P and Q are a statement, like 6 is less than 5 or something like that. Now I'm going to go down, and we'll knock this guy out. So here we go. We have two values, value 1 and value 2. Value 1 is 10 and value 2 is 20. We have an if statement. It says value 1 is less than value 2 and value 2 is greater than 20 not. Okay? So what we have there is a not in front, factored out. And the second if statement completely stacked. Okay, I have a stacked structure here. I have the very same statement above, but with the not distributed in. So let's get something clear here. I know on the top up there we had this not P and not Q, but we don't put a not value 1 and a not value 2, okay? That's not what happens. P and Q are statements, so this entire thing is P. This entire thing is Q. So when I do the not for them, I get a different statement. Let's look down here. See? Not P is value 1 greater than or equal to value 2. That's what the not does here. And I have some nice little notes down here showing how nots work. Not greater than would get me less than or equal to. That's what this arrow is suggesting. Not less than is going to get us greater than or equal to. Now, we don't write this. We don't write this. We write this. Not equal to, going to put a not with 1 equal. Okay, that's how these things are used. That's the translation in code. This is the thinking. This is the code over here. So after distributing this, this less than becomes greater than or equal to. See, nothing happens with these. Okay, it's the whole statement that's being knotted. I knot the and, I get an or. Then when I knot this, I'll get value to less than or equal to 20. So these two statements are exactly the same. We'll run and see what we get. Do we get any success? Yes. We get success. Well, let's see why it was successful. Why did these run? In the first case here, is it true that 10 is less than 20? But we don't need to go any further. We don't need to go any further. Short circuit. Let that one sink in a second. Short circuit. The first statement is false. Made an and, the whole thing is false. But how did it get to print this? There's a not. And a not negates, turns false into trues and trues into false. If the whole thing here is false inside the parenthesis, then we put a not, it turns out to be true. So we print success. Let's go down here. After distributing, I got this greater than or equal to. So let's see, is value 1 greater than or equal to value 2? That is not true. 10 is not greater than or equal to 20. So we move on. See, if it were true, it would have been short-circuited because it's an OR. But because it's false, we need to check the next one. Is value 2 less than or equal to 20? This is true. So because it's an OR, only one has to be true. Whole statement becomes true, and we have success. So these distributing a not when you have actual statements. Not greater than becomes less than or equal to. Not less than becomes greater than or equal to, and not equal to becomes exactly not equal to, like this. Okay? So keep these in mind. Keep the short circuiting in mind. Keep De Morgan's laws in mind. Always paying attention to the introductory video. That brings us to the end of 3.6.